Hello, so today we'll be looking at another aspect of chemistry. I hope you've been enjoying all the chemistry videos made so far. I'm always open to discussions, suggestions, and maybe observations as regard to my videos. So please remember to always like this video as well as subscribe to my channel. Okay, so today we want to look at another topic in chemistry, basically alkanes. Okay, I need to refresh your memory. In previous videos I've talked about introduction to hydrocarbon. So very quickly, can you pause this video and think of one or two things you can remember as regards to hydrocarbon, what hydrocarbons are, saturated hydrocarbon, unsaturated hydrocarbon, and also the various examples of hydrocarbons. So quickly pause this video and do that in 1 minute. So our end in mind for today, we'll be looking at comprehensive understanding of alkanes from their basic structure and properties to their nomenclature, preparation and practical applications. Okay, so when we are talking about nomenclature, know that we are talking about naming, how to name the alkanes. So sit, enjoy the lesson. Alright, so we have this starter activity. What do you know about alkanes? Have you heard about alkanes? Do you have something you can say about it? Pen your response down, either as a group or as an individual. So after you've done that, you can discuss your view with your partner, or you can deliberate on it if you are just the only one watching this video. So pull down examples of alkanes you can think of, then share your thoughts with your class if you are actually watching this in group or as a class. Okay, so let's talk about introduction to alkanes. Basically, the alkanes, they have the general formula, which is CnH2n plus 2, as you can see on your screen. So basically, the N represents the number of carbon. So what we have here, this N represents the number of carbon present in the molecular formula. So in this case, whereby we have methane, the number of carbon here is just 1. So if I'm to write it, it's going to be C1 H2 into bracket 1. So if we now have 2 times 1 plus 2, that's 4. So we can now have CH4. That's how we arrive at this, ethane for CH4. So if we also look at the ethane, the number of carbon for ethane is 2. So we cannot have C2 then H2 into bracket 2. So if we have 2 times 2, that will give us 4 plus 2, that will give us 6. So that's why we have C2H6 for the ethane. So we can actually use this formula here to actually determine the molecular formula for all the alkanes. Okay, so now please note that the arrangement of this family, that is the members of the alkanes, they are in this order from methane to ethane, propane, butane, pentane. So in this case now, the methane actually is actually the first member of the alkanes. It's the first member, like I can just say like firstborn, you know, first member of the alkane. So when you are writing, it's wrong for you to take ethane as one carbon. Anywhere, any case, anytime, methane is always one carbon, ethane is 2 carbon, propane is 3 carbon, and so on. Now when we are talking about formula, we have 3 ways by which we can write the formula. We have molecular formula, we have the condensed formula, and we have the structural formula. Now if you look at this molecular formula, it's actually showing the atoms present in the compound. Now when we looking at let me go with the structural formula. The structural formula shows how the atoms are being arranged, the way the atoms are arranged. Now talking about the condensed formula, the condensed formula is just like a linear form of the formula. It's not really showing how the atoms are being arranged. Okay, so now let's say for instance you are asked to draw the structure of methane. Okay, so what you just need to do, you want to draw the structure of methane. First, try to note that, okay, how many number of carbon does methane have? Methane has 1 carbon, so draw the 1 carbon first. Now carbon is tetravalent. It simply means that 4 bonds can be attached to carbon, so you cannot have 1 bond here, another bond here, another bond here, another bond here. So each of these bonds is attached to hydrogen. Okay, so that's hydrogen. Then we have hydrogen here too, and also here. So this is the structural formula for methane. Please note that there is difference between structural formula, molecular formula, and condensed formula. So if you are asked to draw the structural formula and you are drawing molecular formula, you are totally wrong. Okay, so this for methane. Let's now say you want to draw for. Now always remember the tetravalent rule of carbon, that it can only hold 4 bonds. So put all the bond. This is 1 bond here, this another bond here. Add the bond rather. So then this last one. Okay, now I wouldn't want to waste time putting all the hydrogen, but know that for all these places that we have the bond, then hydrogen will be attached. So let me just include the hydrogen here. Okay, so finally you have been able to draw the structure of pentane. So remember that all these places too we have hydrogen there, but not to waste our time, I won't be including those ones. So you can also try without checking this structure. Try on your own. You can pause the video and just pause the video, then in your notebook try to draw the structural formula of octane or even decane. Okay, now talking about the condensed formula, you will notice something here. Looking at the condensed formula, you know that this H3C represents what we have here. This is the C. then the H, 1, 2, 3. That means that 3 hydrogen is attached to this carbon, which is this. Now here now we have CH2 in bracket, then we have 4. It simply means we have 4 CH2. 4 CH2. This is 1, 2, 3, 4. Now instead of writing them one by one like this, they've put everything together. So it simply means we have 4 CH2. Then the last CH3, this is it. So it's represent, which is carbon here, then 1, 2, 3. So this is just a condensed form of the structure. Okay.
So let's talk about the homologous series. Homologous series is a series of compounds with similar chemical properties and some functional groups, different from the successive member by a CH2 unit, or what we call a CH2 group. Now let's explain. When we are talking about the homologous series, they are just like a family, you know. And under that series, we have the alkanes, we have the alkenes, we have the alkynes, alkanols, alkanoic acid, alkanas. We still have more of them though, but all these, they are under the homologous series. Now, when we are saying that each homologous differs by a successive member of a CH2 unit. Now let's see what that is trying to say, what we are trying to say about that. Okay, now take a look at this. We have methane. We have methane here. The number of carbon is CH4. So, and I just want you to quickly try as much as possible to get familiar with this structure on how to draw the structures we have there, knowing the number of carbon for each of these alkane. Then thereafter we'll now consider how the CH2 group is being expressed here. Okay, so please quickly pause the video and try to learn the structure. Then once you are done, play the video and continue. So when we are talking about the CH2 group, now looking at this formula, you see that we have carbon here, which is 1. We have 4 hydrogen. Now let's compare the difference between this methane and ethane. Looking at the methane is C1, then ethane is C2. So if we have 2 minus 1, that simply means 1. So for this one now, 4 and 6. 6 minus 4, that means 2. So that's how we arrive at CH2. It simply means each of these members, they differ by the CH3. If you look at ethane and propane, this is 3 minus 2, that's C1. Okay, let me try to write down. So now if we look at this propane and ethane, it's going to be 3 minus 2. So if we have 3 minus 2, that will give us C1. Now if we also look at the 8 minus 6, that will also give us 2, which is H2. So we cannot have CH2. So we assume the one is just not visible, so CH2. So that's how we actually arrive at this CH2 units in the definition of the homologous series. So if you look at the series, all these homologous, if you look at all the homologous, you will notice.
Okay, now let's talk about the alkyl group. So basically, the alkyl group, they are derived from the alkanes by the loss of 1 hydrogen atom from the alkane, or we can say by the removal of 1 hydrogen atom from the alkane. Aside that, the alkyl group, they also determine the physical properties of the hydrocarbon. They determine the physical properties of the hydrocarbon. That is, the alkyl group will tell you if they are in maybe gaseous state, liquid state, or solid state. Now, May I remind you that as the number of carbon increases, the state changes. So for instance, it's expected that methane, ethane, they are going to be in gaseous state because they actually have low number of carbon. But as the number of carbon increases, let's say from pentane upward now, we can tend to have liquid states. Now it's going to get to a particular carbon whereby the state will also change to solid. So that tells you that as the number of carbon increases, the state changes. Okay, now talking about the alkyl group, like I said, they are gotten from the parent alkanes. Now take a look at this image we have here. In this image now, you can see this methane here is from alkane, and there's lots of one hydrogen atom, so it becomes CH3. So this CH3 now is an alkyl group, and you can no longer call it methane, but you call it methyl. Now how do we arrive at this name methyl? For you to name any alkyl, it's just for you to replace the ANE of the parent alkane with YL. So you can see that this ANE is being substituted with YL. So this becomes methyl. So methyl is an alkyl group. So can you now try and determine the alkyl group for let's say propane. Okay, so quickly pause this video and try to determine the alkyl group for propane and as well name it. Okay, now let's do it together. Now for propane, so how many carbon is propane? 3 carbon. So we are just going to write the molecular formula. So 3 carbon, so that will give us CH3 then CH2. Okay, I just want to CH2. I'm using the condensed formula, not even the molecular formula. Then CH3. So this is a condensed formula now. So if I want to use a molecular formula, it's going to be C3 H8. So that would be the molecular formula of propane. So if we now remove one hydrogen atom from C3H8, what will it become? Can you tell me? So it's going to become C3H7. Okay, so now this C3H7 is an alkyl. So this is an alkyl. Then if you are naming this now, it should now become what do you think it's going to become? Remember, okay, let's start from the alkane. This is propane. It's propane. What do you think this will now become? We are going to be replacing the ANE with YL. So this will become propyl. So in ANE is now replaced with YL. So this is an alkyl. So you can also try to derive the alkyl for maybe butane, ethane, ethyl. Is that clear?
Now let's talk about your functional group. Just like we said as regards to alkyl group, the functional group, they are basically they help to determine the chemical properties of hydrocarbon. The alkyl determines the physical properties. Now the functional groups helps to determine the chemical properties. And when we are talking about the chemical properties, like that has to do with what reaction and the hydrocarbon can undergo. So basically it's kind of different from the physical properties. Okay, so now by definition we say a functional group are a group of atoms in a molecule that determine the chemical properties of molecules. Alkanes have no functional group, only the C single bond H. Now in most cases when you say alkane, the functional group there is just when you see this bond, that's just the functional group that we are trying to talk about there. So alkane is usually represented by C single bond H. Okay, so but we have other functional groups. We actually have other functional groups like the OH, which is the hydroxy group. Now these are some other functional groups that we have here. So it's very important for you to be able to know this functional group. Looking at this now, this is aldehyde, and this aldehyde is COH. Remember what I said R represents? It represents the alkyl group. So this is ketone. Ketone is CO. Then we have the alcohol, which we represent with the OH. We have the ether, which has O, then two alkyl group attached to it. We have the amine. We have the alkanes, as you can see, the alkene with double bond, the alkyne with triple bond. So then we have the carboxylic acid, COOH. So now I need you to pause this video and I need you to do two things. The first thing you need to do is to try to learn to draw the structure, basically the molecular formula. Just try the molecular formula of 5 members of the alkyl group, talking about the methyl, ethyl, the propyl, the butyl, and the pentyl. Write their molecular formula. Then also try to also get yourself familiar with these functional groups we have here. Basically the carboxylic acid, the esters, the amide, the aldehyde, the ketone, the alcohol, the ether as well. Please get yourself acquainted to them such that you will be able to record them without checking. So we also have another activity here. This activity talks about functional group detective. So read through the activity. You can do it as a class or maybe as individual.
So let's quickly look at nomenclature of alkanes. Nomenclature of alkanes. When we say nomenclature, it simply means naming of alkanes. So there is a body we call International Union of Pure and Applied Chemistry that we call IUPAC. So it's a body that they gave some guiding rules as regard to how compounds can be named. So when we are talking about naming of alkanes, that is nomenclature of alkanes, you have to follow some set of rules. Now for instance, we have something we call the preface. So you use the preface for the number of carbons. For instance, an hydrocarbon with one carbon is called met. Then for 2 carbon is et. Then for 3 carbon is prop. Then for 4 carbon is but. For 5 carbon is pent. So and so on and so on, just like we have discussed earlier on while talking about the members of the alkanes. Also remember that the alkanes they only contain single bond. The alkanes they don't have double bond, they only contain single bond. Okay, so now after you've been able to determine the preface, then the next thing is for you to determine the surface. Okay, you add the surface. The surface is usually ANA. So be it for the met, the et, the prop, the both, is always ANA. So I can easily add methane. So if I add the ANA, it becomes methane. To et now, it becomes ethane, propane, butane, and so on. For instance, we have CH4, which is methane. Okay, now take a look at this example we have here. Like I said, first, if you know that you are seeing 1 carbon, know that is methane. If it's 2 carbon, is ethane. If it's 3 carbon, is if it's 4 carbon rather, is butane. But if it's 3 carbon, is propane. Okay, so now you can see here, but I've also stated this earlier on, that they only contain single bond, which simply means that they are saturated hydrocarbon. They are saturated hydrocarbon. Saturated hydrocarbon, the hydrocarbon with just a single bond. So now we also have another aspect that you also need to know, and that has to do with numbering. If you want to number, now you see in this case now what makes this structure we have here. Let's say for instance the butane. What makes this butane differs from what we have here is that in this case now, this position 2 that you are seeing here, hydrogen is not present here. What we have here is CH3, and CH3 is a methyl group. Unlike the position 2 here is still hydrogen that is present. So that tells you that we have a substituent group attached to this particular hydrocarbon. A substituent group is attached, and that substituent group is methyl group. So whenever you have a substituent group attached, then you also have to name that substituent group. So first you need to consider the straight chain, the longest carbon straight chain, which is the one you are looking at, this linear chain. So we have 1, 2, 3, 4, 5, then we still have 6 and 7 though. Now this CH3 is closer to this carbon here, so it's right for you to start your numbering from the carbon that is closest to the substituent group. I repeat, you start your numbering from the carbon that is closest to the substituent group. Our methyl here is the substituent group, so it simply means it's going to be wrong for me to start my numbering from this methyl here. That is the methyl at the right hand side here. So you have to start from this side. So this will be carbon 1, carbon 2, 3, 4, 5, 6. Now for you to name this compound, you can now first of all look at the substituent group attached. What is the name of this substituent group? Can you respond? Methyl. So you also check what position do I have the methyl is at position 2. Now for me to start my naming, I can now say 2-methyl. Okay, I think I might want to write that somewhere. So I can say 2, then you put an hyphen, 2-methyl, methyl. Now the methyl we are writing is actually this particular methyl here, so it's at position 2. So we have been able to name this methyl. Then you now look at the straight chain, the longest straight chain that we have here. We have 1, 2, 3, 4, 5, 6, 7. So that means that the number of carbon in that longest chain is 7. So we have 2-methyl. 7 carbon is actually ethane. So it's going to be 2-methyl ethane. Ethane. If it's 8 carbon, it's going to be octane. Okay, so I believe you understand that. So can you try to name this compound that we have here? Remember, we have 2 substituent group. This is one and this is another one. Then you consider the longest chain. So try and name it, pause the video and check later. So this is the answer, 2,3-dimethyl pentane. So looking at this now, why do you say it's 2,3? It's wrong for you to start your numbering here. You should start your number from here. So this will be 1, carbon 1, carbon 2, carbon 3, 4, then 5. So now you can now say that we have 2, then comma 3, comma, then hyphen rather. Now because the methyl is 2, that's why we are using di, telling us that we have 2 methyl group attached, dimethyl. Then the longest chain now, 1, 2, 3, 4, 5. And when we have 5 carbon, that's pentane. So that's why 2,3-dimethyl pentane. Let's assume that we have another methyl here at position 4. Then it's going to be 2, 3, comma again, then 4 hyphen trimethyl pentane. So it's going to be tri if we have another methyl group at this position 4. Okay. So you can also look at more examples here. If you look at this, what makes this here different from the is that this is a condensed form. This is its structural formula. The same thing applies to this. So I need you to study this very well and see how far you can go. So also remember that we have some other substituent group like chlorine. It's not only methyl that can be a substituent group. Ethyl, that is C2H5, can also be a substituent group. So chlorine can be a substituent group. Now when chlorine is a substituent group, we call it chloro. If it's bromine, it's bromo. So if it's iodine, it's called iodo. For instance, if I have bromine here, it's going to be bromo. So let's take a look at this activity quickly. 3-methyl Work in group
Pen.
to draw the structure of the following alkanes.
So now,
if you are watching this video as a class, then you can quickly do this, but if you are alone, then you can also do it yourself. So in this case, they are asking us to draw the structure of 2,2-dimethylpropane, 2-methylbutane, then 2-chloro-3-methylpentane. You also have to discuss the rules you use to name them. Present your answers to the class. So you can quickly pause this video and attempt it. Okay, so what do we have? We have this for the 2-methylbutane. This is the structure here. So this is the structure. Then for the 2,2-dimethylpropane, this is also the structure. You can see 2,2. It simply means that the 2-methyl group they are in the same position 2. This is carbon 1, carbon 2, carbon 3. So that's why we are calling it 2,2-dimethylpropane. Then for the last one, which is 2-chloro-3-methylpentane. So in that case now, you can see that we have two different substituent groups, chlorine and methyl. Now the chlorine is at position 2, the methyl is at position 3. So that's why we call it 2-chloro-3-methylpentane. Now, however, in a case whereby we usually follow alphabetically. This case now, chlorine starts with C. It simply means C will come before M. That is, C will come before M alphabetically. So we have to start with chlorine. But let's say that chlorine is at position 3. If chlorine is at position 3, then I have to name it 3-chloro. Okay, let me go over it again. If chlorine is at position 3 and methyl is at position 2, then I will have to name it 3-chloro-2-methylpentane, because alphabetically chlorine comes first. So I have to name chlorine first. So that's what we are talking about as regard to when alphabet comes in. Okay, consider this second one. Name this compound. You see in this case too, we have bromine, we have chlorine attached. So try it, pause the video, then check your answer. Okay, so it's 2-bromo-3-chlorobutane. So I believe you've been able to understand naming of alkanes. So that will be all for today. Thank you.